Have you ever wondered how cross-country skis are made? Or even, what if I could make my own skis and build a skiing empire to take on the likes of Solomon and Fisher? For the gear-obsessed skier in all of us, these are some of the questions that keep us up at night, alongside the perennial question of, which wax should I use for the Berkey? After creating 7 different versions of homemade skis, I've learned a lot, failed a lot, and want to share it with you. Hopefully, I'll be able to give you some insight into the design of cross-country skis and the materials that go into them. The goal of ski design is to achieve a desired pressure distribution along the length of the ski. Different manufacturers target different pressure curves, but in general, the pressure in skate skis is concentrated near the tip and the tail, with a small pocket under the foot where there's no contact with the snow. The base is pretty straightforward. Its purpose is to maximize glide on the snow. Some bases perform better on warm, wet snow, where others perform better on hard, cold snow. Additionally, the way that the base material is produced, whether it's sintered, extruded, or cut from a large roll, impacts its gliding abilities. The core of cross-country skis are often not very strong, but they allow the rest of the materials to form the shape that we're familiar with, thicker at the center of the ski and thinner near the tip and the tail. This shape is crucial to evening out the stresses in the ski. The center point of the ski has the highest bending forces, while the tip and the tail have almost none. To prevent the ski from overcompressing, which would lead to a squirrely ski, the center of the ski is thicker to compensate for the higher bending forces. Additionally, the flexible nature of the core allows the manufacturers to finely tune the camber of the ski. The camber is the swooping profile of the ski that makes the base material sit at different heights off the snow. Ski manufacturers can adjust this camber to create skis for different snow conditions or people of different weights. For example, if you increase the height of the camber, the ski becomes better suited to heavier skiers. Finally, we have materials like carbon fiber and fiberglass that make up the body of the ski. These materials are made of thousands of small strands that are either woven together like a fabric or oriented in the same direction, referred to as unidirectional. Skis often take advantage of unidirectional materials because you can orient them parallel to the stresses experienced within the ski. To prevent the fibers from crumpling when a compressive force is applied, a resin is introduced to the voids between the fibers. These are called composite materials because they are comprised of 2 or more constituent materials, in this case the fiber and the resin. The resin used to stiffen the composite materials can either be introduced to the fibers during the initial manufacturing, referred to as pre-preg, or can be added by the person when creating the final composite part. Next, I'll talk about how I made my own skis. The first step to making skis is designing them in a 3D model. This model has been incrementally modified with every version of ORIF skis, and it includes accurate representations of all the materials that I'm using. However, one of the key points that I focused on was keeping an eye toward the manufacturing process. It's easy to design something, but if you can't manufacture it, the entire model is worthless. Unfortunately, designing skis was just the beginning, because roughly 80% of my time was spent creating molds, trim jigs, and fixtures. All of these steps are crucial in creating a high-quality ski that accurately represents your intended design. The most important and time-consuming of these manufacturing steps is creating molds. In this case, I designed and built 2 different molds, a bottom mold with screws for adjusting the camber, and a top mold for forming the top portion of the skis. However, you can't just make a carbon fiber mold out of nothing. These molds were created using another set of molds that were machined out of a polyurethane tooling board. After sanding the machined surfaces to a smooth finish, I did what's called a resin infusion on the carbon fiber. In this process, the carbon fiber that makes up the final mold is placed on top of the first mold and compressed using a vacuum bag. The resin is then sucked into the carbon fiber using the negative pressure of the vacuum. While time-consuming, the biggest benefit of this process is that you end up with a very strong and dimensionally accurate mold. The next step was bonding together multiple sheets of foam core to create what's called a blank. The blank was then machined to the final shape of the core and sanded to smooth over any machining marks. Finally, it's time to put it all together. The materials were placed in the mold, starting with the top sheet, which is a protective sheet of plastic that contains the graphics for the ski. Everything is then sandwiched together, and a vacuum is pulled on the entire assembly to compress and constrain the skis. After curing in the oven overnight at 275 degrees Fahrenheit, I popped the skis out of the mold and proceeded with trimming. Throughout my time building the 6 previous versions of skis, I created jigs for trimming the excess material on the sidewalls, as well as a 3D printed mechanism for cutting the groove in the bottom of the ski. These are all processes that would be very difficult if it weren't for custom-made tools, so these have been invaluable to my process. After bringing them to Tom at Finsisu to get stone ground, they're ready for testing. With each set of skis, I've made slight adjustments to the camber and the layers of carbon fiber to try to dial in the perfect flex. All of these decisions were dictated by my on-snow testing combined with insight from teams at Finsisu and Pioneer Midwest. Each set of skis has gotten incrementally better, but introduces the occasional step back. This can be disheartening, but the things I've learned from these mistakes are what have gotten me to where I am today. I've dedicated hundreds of hours to this project, but it's easily been one of the most rewarding. It combines my love of skiing and engineering into a tangible project that I can now share with one of the greatest communities out there. Thanks for watching.